Choosing a career as a NASA scientist, most people think NASA mostly involves space exploration, which includes the stars, the planets, and the Earth's relation to the universe. But most people don't know that NASA actually um, has the NASA also does exploration in other fields, starting at Earth to help understand space. Um, are Do you guys know the other fields that NASA goes into besides space exploration?
No.
Okay.
No.
Okay. Um, do you have like a small guess, maybe?
Maybe things to do like with the environment.
Mm-hmm. Yeah. So another thing that what I'm going to talk about here is uh, pursuing a career in through through NASA in aerospace engineering, scuba diving, and traveling. Scuba diving for NASA. Scuba diving is used to train for space exploration. I am personally a certified scuba diver, so this really brings interest to me. What it is that scuba diving is similar to the buoyancy of being in space. Although the difference is that there, when you're underwater, you are fighting the water, and in space, you're not fighting anything. But the trick is buoyancy. Um, so, according to NASA and scuba diving, these are real space techniques for space buoyancy. Um, so this brings a lot of interest, and some people don't know it, but they do actually. The people before they go into space, they learn how to scuba dive first before they explore space. Right here, you can see in this picture over in the left hand corner, um, these space NASA space explorers are currently training on the buoyancy through scuba diving. And on the right hand side here, it's actually showing a fully suited scuba diver, so it's similar. Also, the suit on the far right hand corner shows a full suit. What they call is a full suit diving, and it's basically of I'm sorry, 860 feet underwater, and that's when it gets pretty cold, and the pressure is a lot. The one on the bottom is a more, what is it called? A more updated version of a full suit diving. Aerospace engineering. I'm sure a lot of you may know about aerospace engineering. It's to engineer the rockets and the rovers and the satellites to go to space. Uh, in a special issue on 70 years of aerospace research and technology excellence at NASA Glenn Research Center, this particular article talks about the many it doesn't talk about the explorations, but it talks about the building blocks of engineering for robotics, robotics and the building of the aerospace aircraft. So the fluid components, the material components, which I actually find interesting because um, sometimes some people may think that when you go into space with something, it'll crumple up instantly. And so that's not necessarily true. Um, like when some people may think almost being in water is equal to being in space, which is almost true, but not exactly true. So this article actually goes through the events and explains 70 years of engineering in the working. Also, in the Black Estelle and Library um, at Rock Valley College, I found a magazine titled Astronomy. The title of the article was A Volcano May Have Erupted on Venus in 1991, which I think this is interesting because we, as engineers and travelers, actually, now we have to compare samples and how do we actually identify what is on a planet is we use different rovers and actually what they call it chemistry photography. So basically what they use is a infrared scope to see the different to detect heat and the topography on each planet. The thing about the two volcanoes is that one of them did erupted. Why is this important? It's because this changes the atmosphere of the planet, and once that changes, that can cause radiation towards our planet. Also, I'm sure, well, a lot of people in the science industry already know, but Venus was once habitable like Earth. In fact, Venus is considered Earth's sister. But Venus lost its water, and so most of the atmosphere is nitrogen. Right here explains, I'm sorry, not nitrogen, carbon dioxide. So most of our atmosphere is nitrogen, which actually we're supposed to have more carbon dioxide. Um, we actually need it, but for Venus, as you can see there, there's 96.5% of carbon dioxide. Okay, traveling. So when people think of traveling for NASA, they think of traveling in space. Well, NASA has other occupations where you travel around the world and take samples to compare in labs versus what other rovers may have taken. So this is to tell whether we found maybe extraterrestrial, uh, so to speak, extraterrestrial materials versus what we have known, already detected here on Earth, what is actually original to the planet and what has actually been put there by, say, meteors. Yeah, so, mhm. And here's pictures right here. This woman right here is taking a sample for NASA. And the picture right next to this woman is actually a picture of the iron rich earth. So this is to show the different minerals and everything that's going on there. And remember the Venus volcano that erupted in 1991? Well, the orange picture right below the colorful picture, that is the Mons volcano, and that is the volcano that erupted in 1991. And right next to it is a few pictures of aerospace aircraft, and as you can see, those workers on the bottom are making sure that uh, everything is put together. And right there is the famous Mars rover, and that's a better picture of an aerospace aircraft, and that's a picture of a, what do you call it? Can anyone tell me what do they call the people in suits in space?
Astronauts.
Yeah, astronauts. That's a really good choice. Okay, so pursuing to become a scuba diver, aerospace engineer, and traveler for NASA has always been something that I've been interested in. Another one thing that deterred me was, oh, it's NASA only about space. There's so many other interesting things that involve space, and yes, that is true. And so what I've learned from this speech is that there are careers that offer more than one path, even when those paths have little or close relation. Um, and scuba diving for NASA is a real occupation. Some people don't know that you can be a biologist for NASA and only work on samples on Earth. Some people don't know that you can just work on the chemistry atmosphere of Earth and not work on anything else. Some people just think it's like a room full of people that just do a bunch of math and work on rovers for planets and satellites and aerospace aircraft to travel to space. But that's something that I'm interested in. Thank you.
Thank you. Good speech.
Thank you.